ఓకే ఓకే మండే వస్తావా? సరే 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 మండే పర్సనల్గా వచ్చి కలువు ఒకసారి. లాయర్ మరి మండే ఉంటాడో లేదో. నేను ఎప్పుడు నీకు ఎన్ని రోజులు ఇచ్చారు ఈ రెస్పాన్స్ ఇవ్వడానికి? ఏమన్నారు దానికి? మరి అరెస్ట్ అవన్నీ? ఓకే సరే 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 ఓకే. నాకు క్లాస్ ఉంది, మళ్ళీ చేస్తాను. ఓకే మండే దాని పర్సనల్ మండే పర్సనల్గా వచ్చి కలువు. ఓకే ఓకే బాయ్. Guys, am I audible? Guys, am I audible? Okay. So, yeah. I am feeling okay. Yes. Okay. Can you all log in onto this? Can you just join my Telegram channel, please? Okay. Actually, I got a knee problem. So, doctor has asked to use this stick for few days, not maybe few months. Okay. So, I will try my level best to stand and take the classes. Otherwise, I'll sit and take the class. Okay. Okay. Fine. So, yeah, today is the first class of normalization. Why we need normalization and all I will tell you. But before that, there is a small concept which is very important, which is called foreign key. Right. Now, initially, when the DBMS was invented, there was no concept of foreign key. But something interesting happened in not just in one company, in many companies, something interesting happened. Okay, so there is also a paper written on it. What is the need for foreign key? In that paper, they have discussed what is the need, why do we need foreign key, and they have written everything about foreign key. Okay, you can Google out that research paper. Okay, fine. I will tell you what has happened. Okay, so what has happened was what has happened was what has happened was see. So let us say there is a company. Okay, let us say there is a company. So let us say there is a table called employee table, right? In the employee table, employee ID is going to be there, and then employee number is going to be there, and some other things like the number of dependents on the employee, or maybe there may be something like supervisor ID. Supervisor ID. Okay. 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 And then there is a payroll table. Payroll table. Okay. In the payroll table, all the salary details of all the employees are maintained separately, because initially there was no concept of views. What are views? Not the YouTube views. Okay, I will explain you views later. Initially there was no concept of views, right? So they have separated out confidential data so that only the head of the company, generally the CEO, can access it. Okay, so in this payroll table, employee ID is given, and then the salary is given, and then PAN card, right? And then bank details, bank account details, okay? And then IFSC code, and then there was salary also, salary, right? Now, anyone can see the employee data in the company. So this is open for public. Now they have created the rights in such a way that payroll can be seen only by the CEO or the head of the company or the head HR, someone, and this access is restricted to only few people in the company. Only few people in the company. Oh, someone is spamming. Please provide the schedule for classes, sir. See, there is nothing called schedule. Every day you are going to get 8 hours of classes, and I'm going to finish the entire syllabus for GATE, CS and DA by November in worst case, right? In best case by October it will be over. Okay. Sir, should we write the notes, or you provide the I provide the notes, okay? You please go to my website and register for the course. It is free. I think you have to pay 1 rupee or 2 rupees. Okay, you will get all the lectures along with the notes. Okay, but not this notes. My handwriting is not very good. A beautifully written notes by Vasudha will be provided to you. Okay, can all of you say thanks to Vasudha? Can all of you say thanks to Vasudha? Can all of you say thanks to Vasudha? So Vasudha is writing beautiful notes for every class, and that notes is getting uploaded on the website. And once you log in into the website for the course is free, everything is free. Only thing that we charge is for the test series. Okay, definitely take the test series, because I am the one who is preparing it along with 30 people from IITs and IISc. So our test series will be the best. Okay, and there will be no errors in the test series. And also the test series is very difficult. I made it very difficult. There will be no MCQs. There will be only MSQs and NATs. NAT means numerical answer type. You don't see the options, you have to type the answer. MSQ means multi-select questions. I think you know this, right? So if you take any gate question, it can be of three types. One is MSQ, other is MCQ, other is NAT, numerical answer type. Okay. So MCQ means ABCD options will be given, and there will be only ABCD options will be given, and there will be only one answer correct. MSQ means ABCD options will be given, but more than one of the options will be correct. NAT means numerical answer type questions, means you are supposed to write the answer. You are supposed to write the answer. Okay. Okay. So our test series will contain, I'm talking about the challenging test series. There are two types of test series. One is for gate level test series, where you get all the questions at the level of gate, and the other one is very difficult. So that one we call it as, there we have only MSQs and NATs. You can't choose the answer, you can't guess the answer, you can't discard the answer. You have to definitely know the concept to answer it. Okay. And for the challenging test series, we are providing video solutions as well. We are doing video solutions as well. Okay. Vasudha, please write it in the poster how many video solutions are done and how many questions have been uploaded in the entire this one. Okay. Tomorrow you please send a this one. uh, a poster about how many subjects and what and all. Okay, fine. So let's get back to the topic. Okay, let's get back to the topic. Okay, okay. So where did the concept of foreign key came from? Where did the concept of why Pawan Kalyan photo? Because I am promoting Pawan Kalyan, right? See, I am not a fan of Pawan Kalyan in the movies. My favorite actor is Kamal Hassan. I know you people don't know who Kamal Hassan is. You are from Gen Z, right? Kamal Hassan is the greatest actor ever, according to me. And after Kamal Hassan, I love Amir Khan. And yeah, there are a few other good actors as well, right? But coming to politics, I love Pawan Kalyan. The reason is he came to politics to serve the people. Many people join the parties to earn the money. Many people get into politics to earn the money. But this one guy, Pawan Kalyan, he left everything. Like he has no bank balance. Trust me, a person who earns hundreds of crores not having any bank balance, right? He just gives away. If you say, if you go to Pawan Kalyan and say that, sir, I am very poor and I don't have money to eat, he will take from his pocket whatever money he has and give it to you, right? Right? Okay. So, sir, please watch Chiranjeevi movies also. You may change your decision. I Chiranjeevi is a loser, right? Chiranjeevi, sir. I should not talk about that. Anyway, it is all up to him. Chiranjeevi had the potential, but he didn't have resilience, right? People with resilience always wins. Now, what is resilience? Resilience means falling is not your mistake, but if you don't get up, that is your mistake. Resilience means getting up every time you fail and just forgetting the defeat and again trying. That is called resilience. A leader should have resilience. Okay, determination should be there, willpower should be there, hardworking nature. Otherwise, you can't become a leader, right? I am not interested in politics. I don't want to get into active politics. I can just support Pawan Kalyan. I will just support Pawan Kalyan. Okay, but I am not going to be into politics. Teaching is my passion. I love teaching. See, you are not paying anything for these courses, right? All of them are free. But still, why am I doing it? Because I love it. I love it, damn it. Computer science, teaching is in my blood. Okay. I will not charge anything for my classes. Any class, any course, everything will be free on YouTube. Okay. Okay, guys, let's get back to this. Okay. Let's get back to this. Employee table is there and payroll table is there, right? So in employee ID, there are 1, 2, 3, 4, 5, 6. Let us assume that. Okay. And here also we have 1, 2, 3, 4, 5, 6, 6 employees, right? Now, now the problem is when one employee is removed from the company, fired from the company, or left the company, you have to delete that entry. Okay, from employee table you are deleting it. But there was mistakes. There were mistakes happening in many companies that even after the employee resigns, his information is still going to be present in the payroll and he was getting the salary. That was the problem. That is where the birth of this foreign key has happened. This is the problem. What is the problem? What is the problem? Yeah, I watched Chiranjeevi's movies also. Chiranjeevi is also a great actor. But my personal favorite is, see, Chiranjeevi and this Rajnikant. All these were like mass movies. But if you want to see the acting, if you want to see the class, watch Kamal Hassan's movies. Whenever I get time, I watch old Kamal Hassan movies. Right? Just for 1 hour or something. They are available on YouTube. You can watch them. Okay. You don't know who Kamal Hassan is, just Google out. Google. and I love his philosophy, right? So I know a lot about Kamal Hassan. Okay, fine. Let's come back to this, right? So when you delete an employee, he should be deleted from the payroll too. Otherwise, what happens is he will be getting salary every month. And in one company, it happened that for 20 years, a man has got a salary without working for the company just because of this problem. For 20 years, he got the salary even without working for the company. And once you send the salary, you cannot get it back, right? Right? You cannot get it back. Once you have given salary to an employee, that is gone. You cannot legally get it because you gave him the salary, right? He will say that I was working for the company. Okay, fine. So now how are you going to solve it is the question. Now, how are you going to solve this is the question. Okay, what are the various approaches we have? So we'll take the same example. So let us say there is employee table, okay, and then there is employee ID, and there are other things here, and also there is payroll table is there, okay. Also there is payroll table. Also there is payroll table, and here also you have employee IDs, right? 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 And employee ID is a primary key here as well as a primary key here. Okay. Now what we can do is we can make it a foreign key which is referencing to this employee table CID. This CID, this CID is referring to this CID. This CID is referring to this CID. Right? Right? Now this is called a foreign key. Okay. Now what happens in the foreign key is how do you set the options? See, you have various options you can set in case of a foreign key. Right? So one option is when an employee is deleted from the employee table, his entry should also be deleted from here. Let us say employee number 6 is deleted from employee table. Then employee number 6 should also be deleted from here. Employee number 6 should also be deleted from here. Okay. Okay. But then it is your option. So you have a lot of options. Okay. You have a lot of options which you can do. Okay. You have a lot of options which you can do. I will show you all of them. Okay. So let's now just define the uh, foreign key properly, and then we will go to normalization. Okay. Let's do, I think, 5-10 minutes only. Okay. Let's take the notes about foreign key, 5-10 minutes, then we will go to normalization. Okay. Foreign key. Okay. Let me write FK. Oh my God. FK is not a good word. Okay. So, foreign key is used. These are the textbook definitions. Write them as it is. Okay. Foreign key is used to relate. Foreign key is used to relate attributes, to relate attributes, to relate foreign key is used to relate attributes between the table, attributes between the tables, right? So what does it mean? It means we are talking about relationship. Okay. How are various tables related? How are various tables related? Right? Generally, it is defined over two relations, right? Generally it is refined over two relations. Generally it is defined over two relations. Okay, but there can be single relation also. I'll give you that example as well. Generally, you can write here generally. You can write here generally, because there can be one table also. It is defined over two relations. What is a relation? Relation is nothing but a table. What do I mean by saying this? When there are two tables, if you want to establish a relationship, then foreign key is going to be helpful. Then foreign key is going to be helpful. Okay? Then foreign key is going to be helpful. Why don't you plan you 5 a.m. session? Yes, we are planning. 5 a.m. sessions will start. Who is this? Uh, who is this? JKURE. Okay. Yeah. So we are going to start 5 a.m. classes also. So going forward, we have classes from 5 a.m. to 8 a.m. and then in the evening we have classes from 6 p.m. to 11 p.m. Okay. Okay. I am just not feeling well. See, in fact, now I am not able to walk, right? So I am using this stick. So once let me completely recover. I have knee problem and then a dehydration problem. Let me recover, then you are going to get hell a lot of classes from me. Okay? Okay? Okay. So generally it is defined over two tables. Generally it is defined over two tables. Five, okay, right? But there can be one table also, right? Now these two tables have a name. Whenever two tables are related by a foreign key, they get a name. They get a name, right? So the name is referenced referenced relation, referenced relation, and referencing relation, referencing relation, referencing relation. See, let us say there is a table here. Let's not worry about the name of the table. Okay, let us say there is there is x. Okay, let us say there is y here. Okay, let us say there is y here. I want to have x here. Okay, so here there is one more table which has an attribute x, now if this value of y is a foreign key, if y is a foreign key for the primary key here, y is a foreign key for the sir is, what is it? Are you going to provide the full DBMS course for free? Yes, everything is for free, not just DBMS. Algorithms will be everything I teach will be for free. Okay. So what is that? See, the thing is that I earn in crores by selling the gate subjects. I can easily earn in crores, not just single digited crores. I earn double digited crores. Okay, if I sell the gate course. But then now what happened is I have earned a lot of money because when I started there was no one. I literally minted money. Okay, and I have invested a lot of money in real estate and other investments, and all of them have grown so much that the gate revenue started looking like peanuts. Then I thought, why can't I do service for the poor? Because there are many poor people who can't afford to pay the fee. I am having surplus time and I love teaching. Then why don't I do it? But then I don't want to take money from the students. Okay. Okay. No, everything will be for free. Okay. So don't let me deviate from the class. Write only useful messages. Don't write too many messages. Okay. So reference relation and referencing relation. So if this attribute is referencing to this attribute, right? So we call it as referenced. So this table is called as referenced, REFE, referenced table, right? And this table is called as referencing table. This table is called as referencing table. This table is called as referencing table, right? So next point is a foreign key, let me write FK. A foreign key can refer, a foreign key can refer, a foreign key can refer, 1 minute. So a foreign key can refer, okay, to the same table or to the different table. Okay, a foreign key can refer to same table or different table. I will give you a classic example for this. Okay, now let us say there is employee table. Okay, and let us say there is payroll table, the one that we have seen, right? Payroll table. Now in the payroll table, the employee ID, let us say this is the this is a field. Let us say 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 this is a field. Employee ID. Let us say there is a field employee ID, and here also we have employee ID, right? Now there are two different tables, and one foreign key is referencing to the primary key or alternate key of the other table. So this is an example of relation between two tables. Right? Sometimes even three tables can be related. I'll show you that example also later. Okay, or now using the same example, I will show you how the referencing happens in a I'll show you how the referencing happens in your lecture. Are very easy to understand, and thank you for your great teaching and helping us. Right? Okay, thank you. Who is this? Mohan. Cool Mohan. So now let us say there is employee ID and there is a supervisor also. Let us say there is employee ID and there is a supervisor also. Let us say there is an employee and there is a supervisor also. Right? Now this supervisor will refer to the employee ID. Why? Because every supervisor is also an employee. So before you making him a supervisor, first you have to add him as a employee. Once you added him as an employee, you can use him as a supervisor. So if you look at these two are the common cases. A foreign key can refer to the same table. A foreign key can refer to the same table, or a foreign key can be referred to a different table. Foreign key can refer to a different table. Okay. Okay. Fine. Got this point. That's all. We can take many examples. Okay. Now let us say in this one only, let us say the employees are 1, 2, 3, 4, 5 employees are there. So you have added payroll in the payroll 1, 2, 3, 4, 5, right? Now if you add employee number 10 in this table, which is not present here, this will not be added. That is the advantage of foreign key. You cannot add an employee who is not there in the employee table. You cannot add an employee who is not there in the employee table. Who is not there in the employee table. Right? Right? Now similarly, here also you can do the same thing. Here also you can do the same thing. Okay. So let me just give you the table. Let me just take the values which will make sense. Okay. If I'll take an example which will cover many points. Okay. So E1, E2, E3, E4, E5, let us say 5 is sufficient, or let us say E6. Okay. 6. E6. Okay. 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 Now the employee names are, they can repeat. This is E name. Employee names are, they can repeat. A, B, B, A, B, B, A, B. Okay, let us say A, B, B, A, B is there. Okay, and let us put one more C. Now let us say employee number 1, E1, has a supervisor, right? Let us say E1 does not have any supervisor, which means E1 doesn't report to anyone. He might be the CEO and there need not be any reference, right? Then you can add null. So this is a very important point where many people get confused in many textbooks, right? Whatever I teach is standard SQL, okay? So whatever I teach is final, okay? Whatever I teach is final, right? Yes, everything will be uploaded for free, okay? So now see this, guys. Now see this case. Now we have many employees, right? So if I write E10 here, which means employee number 6 has a supervisor number 10, but there is no entry here of supervisor 10, right? Therefore this one will not be allowed by the DBMS, right? And the beauty of DBMS is you can configure according to your needs. You can configure according to your needs. So one thing that you have to understand is that the foreign key can have null values. You can make a point here, okay? Vazda, you can write this point. A foreign key can have null values. A foreign key can have null values, right? So in this case, both the referencing and the referenced tables are same. Both the referencing and reference tables are same in this one. Both the references and referencing tables are same. Right? 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 Okay. Fine. Foreign key allows null value. Referencing relation record whose foreign key is null is not related to. Let me write them down so that you will also know how to write, what to write. Otherwise, you will get confused. Okay. Foreign key allows null values. Foreign key allows null values. Foreign key allows null values. Right. And then referencing relation right, referencing relation whose foreign key is null, whose foreign key value is null, whose foreign key value is null, is not related to, is not related to any, is not related to any referenced, is not related to any referenced relation, reference relation record, right? So what does this mean? What does this statement mean? What does this statement mean? See this. Here you have null, right? And it is not related to any of these elements. Null is allowed. This is allowed. Foreign key can have a null value because a employee need not have, because a employee need not have, an employee need not have any employees at all. Okay, a employee need not have any employees at all. Okay, 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 fine. Now these points are clear now, right? These points are clear now, right? Now what is the relation between them? So between referenced, between referenced and referenced, between referenced and between referencing, right? Between referencing and referenced, the mapping is many to one. Okay, so don't worry about this mapping. I don't want to confuse you now. Now I have to tell you what is the mapping and what that is all ER diagram ka, ER model ka concepts. Okay, I will teach you when ER model concepts will come. I don't want to confuse you here because without knowing about the mapping, uh, how do you know the mapping, right? So but I have to teach you ER model to understand mapping. Okay, I have to teach ER model to understand mapping. Okay, so before that, now let us see referential integrity constraints. Referential, REFER, referential, referential integrity, referential, this is the name given in the textbook, right? Referential integrity constraints, referential integrity constraints. These are also called as foreign key constraints. These are also called as foreign key constraints. Referential integrity constraints are also called as foreign key constraints. Foreign key constraints. Okay. Now I will tell you about each one by one. See, what is referential integrity? Is the textbook word. It is nothing but foreign key constraints. What are the constraints you are going to have in the foreign key? What are the constraints you are going to have in the foreign key? Right? Right? So, what are the referential constraints are? One is, let us talk about, first thing is, let us talk about referenced relation. Referenced relation. Let us talk about referenced relation. Okay. What do I mean by reference relation? What do I mean by reference relation? See, if there are two tables, okay, if the foreign key of this is actually referring to the primary key or alternative key of this, okay, then this will become referencing and this will become referenced. So that is what I'm talking about. What happens in the reference relation is what I'm talking about. Okay. And one more thing that you have to observe is, one more point that I have to tell you is, foreign key can refer to primary key or alternate key. Write it down somewhere, okay? Foreign key can refer to, foreign key can refer to, foreign key can refer to primary key or alternate key. I hope that I told you, you remember what is alternate key and what is primary key. Now, once you have many candidate keys, you are going to choose one of them as the primary key, and all the remaining keys will become all the remaining keys. Whatever remaining keys are there, all the remaining keys will become alternate keys. Alternate keys, right? Right. Okay, let me give you one example. Okay, let me give you an example. Okay, I will come back to this. Okay, I'll come back to this reference table. Let me give you some example before going ahead. Okay, so now let us say there is a table R where there are attributes A, B, and C. There are three attributes. Okay, and then there is a table S where you have two attributes D and E. D and E, right? Now, here we have A1, 2, 5, and here we have A2, 4, 6, and here we have A3, 6, 10, and here we have A4, null, 12, and here we have A5, 8, and 6, A5, 8, and 6, and here we have A6, null, and 12, A6 null and 12, A6 null and 12, A6 null and 12. Okay, okay, okay. Someone has written Jesus. Very good. See, you can't follow a religion. You have to live a religion. Remember that. There is a lot of difference. Okay, so I follow Islam, I follow Jesus, I follow Hindu gods as well. Every Sunday I go to church and every Friday I go to mosque. I I feel that every religion has something good to learn from, and especially in Quran, if you read Quran, in Quran it is written that heaven is at the feet of your mom. In Quran it is written that heaven is at the feet of your mom, not just your mom. Any mom is fine. Okay. So whenever you meet any mom, just touch their feet. But touching the feet is not there in many religions. It is a Hinduism, right? So I follow everything. I read lot of religious stuff. I read lot of philosophy. I read lot of business. See, what do you think I do the entire day? See, teaching is only from 6 o'clock to 10 o'clock or 6 o'clock to 11 o'clock, right? Just 4 5 hours. And I don't need to prepare anything. Everything is with me in my brain, right? I don't have to prepare for a class. Even if you want me, now if it asks me to tell the synchronization of OS, I will do that. Okay. So I read books a lot, right? And remember that every religion has something good to take and something negative to leave out. And it all depends on your own intellect. Okay. Now, what is intellect? Okay, we are deviating. Let me come back. Okay. We will do that later. Okay. So now ABC, A1, B. So this is the table we have, right? This is the table we have. Now let us say this is the primary key and this is the alternate key. A is the primary key and B is the alternate key, right? Even if you look at A, everything is unique. And even if you look at B, everything is unique, but then nulls are allowed. So here you may note a point that alternate keys can allow null values. 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 Right? Right? So you can make that point. See, from examples you are learning. Here I have given, earlier I have given that a foreign key can have a null value. Now I'm saying alternate keys can also have null values. Let us say DE is there and D is referencing to B. 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 Right? 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 D is referencing to B. Now, what are allowed? 2 E1, 2 E2, null. Null is allowed, right? This is the foreign key. D is the foreign key. Okay. Null is allowed. E3 and then 4 E4 is allowed and then 8 E5 is allowed. Just check this. Okay. When you are allowing twos here, multiple twos, you should have 2 here. Yes, you have 2 here, right? And then when you are allowing 4 here, 4 should be here. Yes, 4 is here, right? Right? And when you are allowing 8 here, 8 should be here. Yes, 8 is here, right? And null values, a foreign key can have null values. Now don't tell me or don't think that this null is related to these two null. No, no, no. Whenever you have a null, it is not related to anyone from the referenced relation, right? 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 So let's now talk about the rules. Okay, what are the various configurations possible? See, in DBMS everything is configurable. In DBMS everything is configurable, right? Prabhat is asking why Pawan Kalyan is in thumbnail. Because Pawan Kalyan is a man who says no to money and he got into politics only to do service. He doesn't need to earn. He is not in politics to earn money. Now that kind of leaders are required. If I don't if I'm not doing anything for the poor, at least I should support a man like that. Okay, who is doing a lot for the poor. Okay, okay, cool. Okay, now we will see the rules. Okay, we will see the differential integrity constraints. Okay, we will see the referential integrity constraints. We will see the okay. We will see the referential integrity constraints, especially reference relation and then referencing relation. Okay, with examples I will explain you. Okay, we have a lot of time, so I go very slowly. Right now we are about to complete 1 hour. Okay, so after 1 hour I'll give you break for 2-3 minutes. Okay, okay. Now reference relation. Okay, so for example, in reference relation, when you insert, see, let me draw a table here. Okay, let me draw a table here. So let us say there is a table. This is student table. Okay, this is student table and this is enroll table. This is student table and this is enroll table. Right, right. This is student table and this is enroll table. Right, right. Let me fill some water and come. Okay, just 1 minute. Okay. Okay. So now there is student who gets enrolled in a course. Okay. Let us write like this. There is a student ID, and then there is a course. Okay. Then there is a, let us say, name, student name. I'm just making it simple. Okay. And enroll is which student has enrolled in which course. Obviously, a student cannot enroll in a course. A student cannot enroll in a course. We can have one more table called course table. COURSE, course table. Okay. Just to give you some input, 1, 2, name is AB, something like that. Okay. Now student number 1. Now we need courses also, right? Course ID, right? Let us say course ID, and then let us say course name, okay, course ID, course name, course ID, course name, course ID, course name, and then instructor. Let us say there are two courses, one course name is DBMS and the other is fourth. Other course is Algo, and the instructor is Coreman, right? Now what will this table have? This table says who is the student and what are his registrations. He is registered in course 1, and the student number 2 has registered in course 2, and again student number 1, same student may register to the second course also, and again the student number 2 may register to first course also, right? Now if you observe it, for this table, for enroll table, you cannot use SID as a primary key or CID as a primary key. SID and CID, they cannot be primary keys because they are repeating, right? I told you primary key should not repeat. So SID and CID cannot be primary keys. Then what happens? A combination of SID CID, a combination of SID CID, a combination of SID CID can be a primary key, right? So we have seen earlier also such a model where a combination of more than one attributes is the candidate key, right? Right? Someone is asking, will I take classes? Someone is asking, will I take classes? Okay, fine. Now reference relation, and we are talking about insertion. Okay. Now what is the reference relation? Let's forget about the third one. See, this one refers to this. A student has to be in the student table before he enrolls for a course. And similarly, every course that is present in the course ID can only be enrolled, not the other courses, right? So we have a foreign key referring to the primary key of one table and a foreign key referring to the primary key of one table, right? So now the question is, see, by looking at this diagram, you can answer why am I doing diagrams more in DBMS. The reason is, by looking at the diagram you will learn a lot of things. By looking at the diagram you will learn a lot of things. See, one question that I can ask is, a single table can have any number of foreign keys. A single table can have any number of foreign keys. Okay, a single a single table can have any number of foreign keys, right? And these foreign keys can refer to different tables. Okay. Okay. Now for the sake of understanding, in this example, what is the reference relation? See, student is the reference relation and course is also a reference relation. But let's forget about course for some time. Let's keep it simple for the discussion. Now I'm talking about the student table, reference table. See, why am I writing like this? For your understanding only, okay? Reference relation means student. Reference relation means student. Reference relation means student, right? Right? Reference relation means student. Reference relation means student. In this example, right? Student table. Now, what happens for insertion? When you try to insert any record in the student table, when you try to insert any record in the student table, okay, okay, there will be no violation. There will be no violation of any rules. No violation. You can do it, okay? No violation. No violation of any kind. No violation of any kind, okay? But, 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 someone has written a comment. Sir, does null value in foreign key attribute mean the value doesn't exist in the reference? Yes, yes. Value doesn't exist in the reference relation. Because if the value doesn't exist in the reference relation, then it will be allowed to be added. Yes, if you want to insert a foreign key without any referencing, then you can make it null. That is okay. Okay, who is this? Who is this guy? Atre. Who is this guy? Atreya GH. Okay, okay, okay. Fine. So it is all. It is 1 hour. We will take a quick break for 5 minutes. Not for 5 minutes. Take a break for 3 minutes. Okay. Take a break for 3 minutes and then we will start. Okay. Take a break for 3 minutes and then we will solve. We will start. Okay. Hello. Just wait for 2 minutes. Okay. We'll start in 2 minutes. Okay. So when you're inserting some new student, am I audible? I hope I'm audible, right? When you are inserting a new student into the student table, there will be no violation. You don't have to worry about it. Okay. But then when you delete, okay, when you delete, there may be many violations, and you have to, when you delete, when you delete something from the student table, there will definitely be, there may be, okay, not definitely, there may be, they may cause, they may cause violation, they may cause violation, right? And how are you dealing with the violations? There are many ways. See, it is all up to the database administrator how he wants to uh, deal with the violations. Okay. So one violation is on delete no action. On delete, on delete, on delete no action. On delete no action. What does this mean? This means that deletion is not allowed. Okay. What is the meaning of it? Deletion is not allowed. Deletion is not allowed. Okay. Okay. There may be some examples where we don't want to take any deletions on the reference table. Okay. 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 There cannot be any deletions. Right. For example, I don't want to take his name. There is a very big guru. Everyone follows him like hell. He has a beard and he speaks good English. Right. And he says that there is no purpose to life. Is there no purpose to life? Do you think that we are purposeless here? See, these gurus, they say anything they want and then they laugh. There is no purpose to life. That is crazy. And you people, Gen Z, are big fans of these gurus. You know, you don't like logic, you want magic, right? That is why Babas are more popular, not Babus. There is a purpose to life. Okay, what is the purpose to life? A beautiful death. That is the purpose to life. When you die, at least 4 people should get heart attack and they should die. It happened with Rajshekar Reddy sir, ex-CM of Andhra Pradesh. When Rajshekar Reddy passed away, many people got heart attacks and they died. What a beautiful death is that! Like a king never goes alone, right? A king never dies alone, right? So purpose of life is a beautiful death. And don't stop following these babas. What do they know? Yoga, meditation. Okay, that's it. And you are donating, and you know how big his house is. The idiot that I am talking about, you might be knowing, white beard and stupid turban. And then he will be taking classes in very big colleges, telling people that there is no purpose to life. Right? Right? There is purpose to life. And you know what is a beautiful death? Doing something that you love. Have you heard about Abdul Kalam? Abdul Kalam died while taking a speech in a college. While taking a speech in a college, he died. He died doing his favorite job. What a beautiful death Abdul Kalam had. And you know what are his things? What are his belongings after he died? 3 blue shirts and 3 blue pants. Only 3. And lot of books. That is a life that you should aim for. A beautiful death is the purpose of life. Okay, you can say that RBR is contradicting with some guru. I contradict myself. Okay, fine. Okay, fine. So on deletion, no action, which means on deletion, deletion is not allowed. On deletion, deletion is not allowed. Okay, okay, okay. On deletion, no action is one of the options. And then the second option is on deletion. Second option is on deletion, on deletion, cascade. On deletion, cascade. What does that mean? On deletion, on deletion, on deletion of the, on deletion of the referenced, on deletion of the referenced on deletion of the reference relation, on deletion of the referenced relation record, reference relation record. If you delete something from the student, on the student, then 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 all the related, then all the related, then all the related referencing, then all the related referencing records, all the related referencing records are deleted. All the then all the related referencing relations are deleted. What does this mean? This is one of the options. One option is don't allow deletion at all. If someone tries to delete it, no action should be taken. And what is the other option? On deletion, you cascade. What do I mean by cascade is, if you are deleting something from here, you delete that from all the referencing attributes. So what does this mean? If I delete 1A, okay, student number 1 is deleted, but student number 1 is referenced here and here, right? So you have to delete this one as well as this one. That is the meaning of it. Okay, let me use a different color. Okay, so what I mean to say is, if you delete this student from the student database, if you delete the student in the student database, okay, okay, you are going to delete this one and this one. This is called cascading. Okay, this is called cascading. And there is one more option. Okay, there is one more option. I will show you that option also. Okay, there is one more option. I'll show you that option also. Okay, there is one more option. I'll show you that option also. Okay, on delete set null, on delete, on delete, on delete set null, on delete set null, on delete set null. What is the meaning of it? On deletion, on deletion of referenced, which means the student table, referenced, on deletion of referenced referenced relation, they are all from textbook. Okay, write it as it is. On deletion of referenced relation record, referenced relation record, on deletion of referenced relation record, set 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 null, set null, set null in all, set null in all related, set null in all related foreign keys, set null in all related foreign key values, right? So this is one of the option. What you can do, on deletion of a record from student table, you can put the null values to all the related foreign key values, right? For example, if you are going to delete this, right? Okay, on deleting 2, on deleting 2, on deleting 2, set as null, which means this set, see, on deletion set null, which means don't delete this, just set it to null, and here also just set it to null. So you can choose to use any of these three options. You can choose to use any of these three options, right? And similarly, now we have to see what happens on update. See, till now what we are seeing, if you observe it, we have seen on insertion what happens, right? On insertion nothing happens, right? On insertion there is no violation, but only in deletion there is violation, right? And what are the actions that you are going to take? On deletion, no action. On deletion, cascade. On deletion, set null. These are the three options you can choose as a database administrator. Once the DBA, database administrator, makes these decisions, they can only be changed by DBA, database administrator, because he has the highest access rights, right? Right? So I hope you understood this. I hope you understood this. Harsh Patel. Harsh Patel is saying there is no God. How can you say there is no God? How many of you think that there is no God? Harsh Patel is saying there is no God. How many of you think that there is no God? How many of you think that there is no God? I'm not able to see the comments somehow. I think there need to be settings or something. See, there are two gods in the world. One is your dad, other is your mom. There are gods, right? Your mom is a god, your dad is a god. Every day after I wake up, I touch the feet of my mom because there is Jannat, heaven, at the feet of your mom according to Quran. And my dad doesn't stay with me, but whenever I meet him, I'll touch his feet. So gods are there, right? Don't say that there is no God. Okay, okay, fine. Now let us see this. So on deletion, you can do all these things. Okay. Now there is one more case that we need to, there is one more case that you need to address. Okay. There is one more case that you need to address. right? So what is the other case? What happens on update? What happens on updation? When you do some updation to the reference relation, which is student in this case, right? When you do some updation, there may be violation. There may be violation, right? There may be violation. There may or may not be. May be violation, right? And how are you going to handle it? Just like how you handle the delete. Just like how you handle the delete, right? Right? On update, on update, on update, no action. On update, no action. On update, on update, cascade. On update, cascade. Or on update, set null. On update, set null. I am not going to explain you all this. One is here, updation is not allowed at all. That is the call taken by the DBA, database administrator. And on update cascade, what do you mean by cascade? Let us say there is one more record 3C and there is 3 and then CID, right? Now let us say I am updating this 3 to 4. Now this updation should cascade, which means here also 3 should become 4. This is called an updation cascade. Now what do you mean by an updation set null? If you change 3 to 4, here instead of 4 you have to write null. Same thing as delete. That is why I am not teaching you. Okay? Same thing. Same thing. Same thing. Okay? 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 Okay. Now this is all about the student table, which is the reference table. Now let us see the same. Let us do the same. Let us do the same with the referencing table. Okay. Let us do the same with the referencing table. Okay. Let us do the same with the referencing table. I don't want to erase it. Okay. Let us do the same with the referencing relation. Referencing relation. What is referencing relation here? Enroll, right? So it is not student, it is enroll. Just for your understanding, I am writing it. Okay. It is enroll. Enroll. Okay. It is enroll. Okay. Okay. Oh, I forgot to take a vitamin pill. My doctor has given vitamins pills and I'm supposed to take them at 8:30. I will just take a pill and I'll be back. Okay. Yes, everything will be free. Each and every class will be free. Okay. So tomorrow I will announce it. Okay. Tomorrow I will announce it. Okay. Okay, now referencing table. Now in referencing table, insertion may cause a violation. In the referencing table, insertion may cause violation. Insertion may cause violation, right? If there is if there is a violation, if there is a violation, if there is a violation, then if there is a violation, then no insertion is possible. Then no insertion is possible. Then no insertion is, if there is a violation, then no insertion is possible. If there is a violation, then no insertion is possible. If there is a violation, then no insertion is possible. Now coming to delete, there is no problem with delete, right? You can delete anything from enroll, right? So you can, for example, what is the first rule says? Let us, we are talking about enroll table, right? So let us say I am inserting something into the enroll table. Let us say I am inserting a student number 10, okay? And student number 10 is not present in the student database. This student number 10 is not present in the student database. So there is a violation. That is why this insertion will not happen. Okay. So insertion, there may be violation. If there is violation, there is no other option. There will be no insertion possible. There will be no insertion possible. No insertion possible. Right. Now updation. So when we are deleting, deletion, no violation. When we are deleting, there is no violation. You can delete any element from this enroll. Insertion may cause a problem, but when you are doing deletion, there is no violation. You can delete any entry you want. Okay. Now what about updation? Updation may cause some problems. Okay. For example, here there is a student number 1. Okay. Just assume that it is not deleted. There is student number 1. Now, if I change this student number 1 to student number 10, that is an update. Then what are you writing? Okay. So when I update, there can be violation, right? Maybe. There may be violation. There may be violation. If I update, there may be violation. May cause violation, right? Therefore, no update if violation is there. That's it. Okay. So these are called as referential integrity constraints in the textbook language. In plain language, you can say foreign key constraints, but in every textbook it is written as referential integrity constraint, but then it is actually foreign key constraint. Okay. So with this, we have completed the entire foreign keys or the entire keys. Now you know what is a super key. Now you know what is a candidate key, what is a primary key, what is the alternate key, what is a foreign key. You know all the keys now. Okay. So now we are comfortable to move on to the topic called normalization. Okay. Now we are moving on to the concept called as normalization. Okay. So what are the important things that are there in the normalization? And normalization is very important. Okay. Normalization normalization is very important. Normalization is very important. Okay. Let's take a break for 2 minutes. Okay. It is, I think you are drained. Okay. Why you said GATE is stupid exam? GATE is a stupid exam, right? I still say it. You learn the subject from me. Don't write GATE. Go and do abroad, masters abroad. GATE is such a stupid exam. No one should write GATE exam. Is it not madness that when 2.5 lakh people are writing, there are only 1000 seats in IITs? Are you crazy to write GATE exam? Learn the subject. You will get into Google. If you learn my subject, you will get into Google. You don't have to do masters, right? Or if you want to do masters, then do masters abroad because you will get a US job, right? And you can easily retire. GATE is a stupid exam. I still say it. I have been saying it for the past 5 years. No one is listening to me, right? But all of you are here because I am the best teacher for GATE. And I love teaching. So, see, I love teaching. So, I am teaching subjects, GATE subjects. Okay. But should you write GATE? No, you should not write GATE. Go do masters in US. You will have an amazing life. Even those 2 years or 1.5 year or 1 year which you do masters in US, even they will be beautiful. Your perspective will change. Your perspective will change. Okay. Okay. So my request is don't 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 write GATE. Okay. GATE is a stupid exam. You will get loans. You will get loans. Okay. You will get loans. Okay. Let's take a quick break for 2-3 minutes and then I will start normalization. Okay. Let's take a quick break for 2-3 minutes. Then I will start normalization. Okay. See, if your aim is to become an IITN, if your aim is to become an IITN, okay, there is no better teacher than me. If your aim is to get into Google, there is no better teacher than me. Acha, how many of you want me to teach GRE as well? How many of you are planning to do masters abroad? How many of you want me to do free GRE courses? GRE, both the mathematics and English. I am very good at it. Any competitive exam you take, I am very good at it. I just lost 4 marks in GRE. Just 4 marks in GRE. I can show you my screen, this one also, a screenshot of my results. I just, this one. GRE is a very easy exam. GRE is 10th class mathematics and 10th class English, right? And in fact, you don't have to write GRE to go to US. Many universities accept just a English proficiency test. You can take Duolingo test, and that is very easy and cheap. Okay. Anyway, there are other. We are not doing all that because that requires a lot of manpower. Okay. So we are not here to help you get into study abroad. We are here only to teach you GATE computer science and GATE DA, right? So yeah, that's it. Okay. Just 2 minutes ka break, then we will continue. Okay. So no one wants me to teach GRE, is it? Yes, Gate DA course is also free on YouTube. Okay, you don't have to pay any money anywhere. If you already paid, you have wasted your money. Okay, normalization, right? So, what are the things that we are going to learn in normalization is we are going to do introduction to database anomalies. Introduction to database anomalies, right? Introduction to database anomalies. Can someone send me the link of this course? Vishnu, can you WhatsApp me the link of this course? Someone wants to join, but they don't know the link. Okay. So, what are the things that we are going to discuss? What are the things that we are going to discuss in normalization? Introduction to database anomalies. Okay. And second one is functional dependencies. Functional dependencies. We are going to look at functional dependencies, right? And then we are going to discuss attribute closure. We have discussed already attribute closure. Attribute closure, right? And then we are going to see, membership test. Already we discussed all this, most of them. Membership test, and finding candidate keys. We are finding candidate keys and super keys. We have done this, right? But it all falls under the topic of normalization. And 5 is lossy join and dependency preserving. Lossless join, lossless join, lossless join, and dependency, lossless join, lossless join, and dependency, lossless join, lossless join, and dependency preserving decomposition. Dependency preserving decomposition. Dependency preserving decomposition. And then we are going to see normal forms. And then we are going to see normal forms, right? What are the normal forms? First normal form, second normal form, third normal form, first normal form, second normal form, third normal form, BCNF, 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 Okay, all this, and then finding the highest normal form of relational schema. Finding highest finding highest normal form of relational finding highest normal form of relational schema. Finding the highest normal form of relational schema. And also decomposition. Decomposition of higher normal forms. Decomposition of higher normal forms, right? And then there is multi-value dependencies and fourth normal form. We don't go till here. We don't go till MVD and multi-value dependencies and fourth normal form. This is not there in the syllabus. Okay. And canonical cover. Canonical cover of FD set. 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 Right. This is also called as minimal cover. Minimal cover. It is nothing but minimizing the FDs, right? So we are done with most of it. We have seen functional dependencies, attribute closure, finding this, and we have to see some of the other things. Okay. So what are you spamming? Don't spam, no. Ask one time. Why do you want to spam the chat? Why do you want to spam the chat? Why do you want to spam the chat? Hello sir, I'm currently working as mainframe developer with 10 years of experience. I'm trying to switch to cloud-based company. Shall I do any AI or cloud certification, or refreshing DSA will be sufficient? Refreshing DSA will be sufficient, Kiran. Just refresh DSA. See, after this TOC and DBMS are over, I am going to start with DSA, data structures and algorithms. Okay. Now, if you prepare data structures and algorithms I left PW. If you prepare data structures and algorithms from me, they will be sufficient. You will be easily be able to get any job in Google, any job like Google. Okay. So while covering DSA, I will cover LeetCode problems also. You know, in Java. Okay. So in Java, I will cover LeetCode problems also. And I don't know if I will be doing Java course, because that is not related to Gate. I want to complete everything related to Gate first. Okay. Then if the time permits, I will do Java and LeetCode problems. Okay. Yes, I left PW. Okay. I left PW. Can't you see the symbol here? Here. Can't you see the symbol here? Raudra. How many of you know the meaning of Raudra? What is the meaning of Raudra? Can someone write it on the comments? Okay. Now let us see. What about normalization? Normalization normalization of database normalization of database is used to eliminate normalization of database is used to eliminate or reduce redundancy is used to eliminate or reduce redundancy in database table in database tables. Okay, so if two or more independent relations or if two or more independent relations okay, if two or more where are we? Normalization, right? If two or more independent relations are stored, they're all textbook terminology. Use the same terminology, okay? Don't write on your own. That is why I'm copying it. If two or more independent relations are stored in a if two or more independent relations are stored in a single relation in a single relation then it forms redundancy if two or more independent relations are stored in a single relation then it forms redundancy right. So already we have seen, I will show you an example, okay? I'll show you one example. Already we have seen that student table and course table are independent. Student table and course table are independent, right? Let us assume that in the student table there is student ID, student name, date of birth. Student ID, student name, date of birth is there, okay? In course there is course ID, course name, instructor, right? Course ID, course name, instructor and fee. and fee are given. Course ID, course name, instruction, and fee is given. Course ID, course name, institution, and fee is given, right? Now these are two independent tables. These are two independent tables, right? Now what happens if I combine these two independent tables is you will get redundancy, right? If I combine these two tables and make them into one single table, which means like this. SID, S name, date of birth, CID, C name, instructor, CID, C name, instructor, fee, instructor fee, instructor fee, right? Right? So I'm combining two tables into one table. 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 Right? I'm combining two tables into one table. Okay? Okay? So, S1 A 1990, this is about the student information. Okay, now let us say he got enrolled in the course C1 and the course name is database and the instructor is Koth. Instructor is Koth and fee is some amount, let us say 1K. Right, right. Now there is a student S2 whose name is A, same name, and who is also born in 1990. Right, right. And then he has also taken the course C1, which is database, and instructor name is Koth, and the instructor name is Koth, and the fee is 2K. Fee is 2K. Acha. Database course will keep it at 1K only, okay? Because you cannot give two charges to the same course, right? And then there is S3, whose name is B, and whose date of birth is 1998. 1998, and the course is C1. He has taken course C1, which is database course, database by course. Let us say fee is 1K. Right, 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 right. And then there is one more student S3 and the name is B. There is one more time I'm writing S3 and the name is B and his date of birth is 1998. Why am I writing again? Because he has enrolled in a different course. Course number 2, let us say, which is algorithms, and the author is Coreman. Let us say algorithms is costly 2K. Algorithm is costly 2K. Algorithm is costly 2K. Right? Algorithm is costly 2K. Right? Raudra means righteous anger, indignation. Do you know indignation? Indignation means righteous anger. I have anger and which is right. I want to change many things in India. I don't want to get into politics, but still I will play a major role in bringing great reforms in India. I am not working for any party. Yes, I'm a member of Janasena party because of Pawan Kalyan, but I will never contest in any elections. Okay, I don't want to be MLA or MP or anything. If I wanted to be an MLA, by now I would have been an MLA. I have that much money and influence. Okay, but that's not the case. I'll fight against any government. Raudra means anger, righteous anger. Okay, and also Raudra has one more meaning as well. I will tell you what Raudra is. See this, Raudra, right? Ra means Ravi, Ud means Udaya, my wife, and Ra means Ravula, right? Ravi, Udaya, Ravula, and Raudra stands for indignation. So there is a lot of thought gone into naming this. Okay. I never wanted to be a billionaire. Never. I was content with what I had. See, coming from a very poor background, seeing crores of money in 20s, just when you are in 20 years, 25, 26, if you are seeing crores of money, you will become content. You will not aim for more. But now I have got this uh, I'm now having a dream of becoming a billionaire. When some small stupid people who teach one or two subjects, that too for 10th class students, when they could be billionaires, I teach 20 subjects and all these subjects with clarity, and I deal them. See, I teach 20 subjects for computer science, right? DA and CS together. There are only three subjects in IIT JEE: mathematics, physics, and chemistry. And one person has taught only one subject and he became very popular. If he could become popular by teaching one subject, how could I not become popular if I'm teaching 20 subjects? So, next year I'll be getting into IIT JEE. Okay, this is the last year I am teaching GATE and I want this to be perfect. Okay, okay, cool. I don't want to become a billionaire because I need money, but I want to become a billionaire because I can influence many people and also I can do a lot of good for poor people. The last check that I write in my life should bounce. My bank balance should be zero by the time I die. I am not going to pass on any money to my daughter, or in case if I have more, in case if I am going to have one more daughter, I am not going to pass any money to my daughters. Okay, I am going to see that all my earnings are gone to the poor people, especially for education. Okay, all this we'll discuss. Okay, this is not the time, this is the DBMS time. We'll discuss all this in a separate video. Okay, fine. So there is S3 and student number 3 has enrolled in one more course. Student number 3 is enrolled in one more course. Okay, C3, let us say it is OS by Galvin. Let us say it is OS by Galvin and the fee is 3K. Okay, now if you look at the table, there are some redundancies. If you look at the table, there are some redundancies. Okay, హాయ్ ఈత, హాయ్ చెప్తావా ఒకసారి స్టూడెంట్స్కి? ఒకసారి రా, హాయ్ చెప్పు, హాయ్ చెప్పు ఒకసారి ప్లీజ్. చెప్పు. హలో ఎవ్రీవన్.
Hello everyone.
హౌ ఆర్ యూ?
How are you?
ఆర్ యూ ప్రిపేరింగ్ వెల్?
Are you prepared well?
Is my dad teaching good?
Is my dad teaching good?
He says me that He says me that
He says me that
he is the best teacher in the world.
he's the,
Acha, he tells me, says others, he tells me that
he tells me that
I am the best teacher in the world. That
I'm the best teacher at the world.
In the world.
In the world.
Okay, go.
ఎప్పుడు చెప్పవాలి ఎప్పుడు చెప్పవాలి
నేను చెప్పాలా ఆయన చెప్పించా లేదు క్లాస్ అవ్వలా ఇక కొంచెం ఉంది అయిపోద్ది కొంచెం ఉంది ఓకే లాస్ట్లో ఉంది ఒక టాపిక్ ఓకే okay my video has paused why is it paused hello let them wait there is no problem they will wait okay ask them to join and tell him that I will join in 10-15 minutes okay I may take 10-15 minutes in every meeting you are going to say the same let them come and wait okay and don't call me okay I will join just drop a message that we have a meeting and if I don't respond to the message then call me okay I am in the class okay bye okay now you can see that there is lot of redundancy here right now you can see that there is lot of redundancy here right now what is redundancy if you see this part is redundant right this is repeated 3 times and if you see this part is also redundant right you are many times adding courses many times adding students so these are redundancies right and you may think that this is also a redundancy but this is not a redundancy why because two students have same name and same date of birth you don't have any option you have to store it this is not redundancy this is redundancy and this is redundancy right now what are the problems that come because of redundancy what are the problems that come because of redundancy okay problems because of redundancy right these are also called as database anomalies right so what are the various anomalies we have insertion anomaly what do we mean by insertion anomaly is if you have to insert a course for example in the previous example if I want to insert a course I cannot insert it without having a student enrolled for the course see every row here if any course has to be added it has to be enrolled by at least one student otherwise course cannot be added right and now here what is the key here SID and CID both put together is the key right okay fine so insertion anomaly in order to insert course data if you have to insert course data you should at least to add one student, right? We need to at least, we need to insert, we need to insert at least, we need to insert at least one student. We need to insert at least one student. Also, in order to insert one student, in order to insert one student, we need to insert one course. We need to insert one course. We need to insert one course, right? So that is the insertion anomaly. And what about deletion anomaly? There is something called as deletion anomaly, right? There is something called as deletion anomaly. There is something called as deletion anomaly, right? Now what happens is the same information is present at multiple types, right? So if you see this, if I delete student number 3, we will be losing course 2 and course 3. If I delete this student number 3, automatically course 2 and course 3 are also going to be deleted. Course 2 and course 3 are also going to be deleted. That is why it is called deletion anomaly, right? So what is deletion anomaly? To delete S3, student number 3, if we delete, let us write this. If we delete student, S3, then what are the courses getting deleted? C1 is anyways here. C2 and C3 are lost. Okay. If you delete student number S3, then C2 and C3, C2 and C3 are deleted. C2 and C3 are deleted. C2 and C3 are deleted. Right? And then there is update anomaly, which means when you update, it may, when the data is redundant, some of updates may be applied to some of the data, but not to all. Let us say I want to change date of birth of S3. Okay, I want to make it as 2000. Now the problem is there are 2000 student number S3 is at multiple places. His date of birth is present at multiple places. His date of birth is present at multiple places. So that may lead to updation anomaly. What is it? If some data is updated, and we fail if some data is updated and we fail to update the redundant data, right, redundant data, it will cause inconsistencies. It will cause inconsistencies. It will cause inconsistencies. Right? 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 Okay, we will end the class here. Okay, we will end the class here. Tomorrow I will continue this. Okay, same time. Acha, tomorrow is Sunday, right? Tomorrow at 8 p.m. we have a important event. Okay, tomorrow at 8 p.m. we have an important event. Okay. Okay, guys. Bye. See you all. Thank you so much. Okay. Thank you so much. Okay.